Hey guys, this is going to be our application for for those determinants. I should step back. And excuse me. This is pretty cool of an application. And what was interesting, guys, when I was in school a long time ago, matrices weren't really created or whatever you want, weren't really discovered in math because matrices basically came from computers. I mean, we have all seen the movie The Matrix, or you've heard of the movie The Matrix. Matrices kind of came out of computer development. And then obviously mathematicians went through and decided, oh, wow, matrices can do this and that. So different, mainly college professors do a lot of research on math and stuff. I know that doesn't sound fun to most of you, but they came up with different ways to use matrices in math. I mean, one of the cool things, now again, you might not think it's cool and it's going to be pretty challenging, but I'm going to break it into small chunks. We can use determinants to find the area of a triangle. Now, guys, that doesn't seem like a big deal, but it really is. If you think back in geometry, we had to find the area of a triangle. If you remember, it was 1/2 base times height. But if you remember, the height had to be a 9-degree line, remember? So like on this triangle, I really couldn't find the area because I would have to actually solve and bring down that 90-degree line, if you remember. If I was going to try to find the area of this triangle, I would need the height coming down. Remember, it has to come down to 90. Well, if I don't know how long this line is and I don't have any really way to find the length of that line, you're kind of stuck. You can't really find the area of that triangle. But mathematicians came up with a way of using matrices to find the area of a triangle. Now, it's pretty complicated, and again, we're going to break this down into many different sections, but I just wanted to show you how you set up the area of a triangle into a matrix, okay? Now, this is the formula, okay? In the front is plus or minus 1/2. So it's kind of like the 1/2 base times height, but it's plus or minus, and here's the reason, guys. When we put these numbers in, you might get a negative answer at the end. So what we're going to do is we're going to do some determinant things with the numbers in here. At the end, if the answer is a negative, then we're going to multiply by another negative because, guys, think, area is the space inside. Area can't be negative. So if you have a negative answer, then you multiply by a negative 1/2, and the negative and negative makes positive. If the answer you get down here is positive, you just multiply it by positive 1/2 because you get asked to stay positive. Again, we'll get into more of that on the next few videos, but in front of the big matrix is a positive or a negative 1/2. Now, what we're just going to practice on this first video is how to put these vertices, the vertex points, into the matrix. And again, just write it down. It's going to seem weird, but it works. Okay? Each of these XY points go in a line of the matrix. So 1, there's my point, 1, 2, 1, 2 goes here. The next point, 3, 7 goes here, and then the other point, 6, 1 goes here. Now you can see I left room here, and I know this is weird, but guys, the last line in this matrix to find the area is all ones. Okay, so this is a 3 by 3 matrix. Vertice, 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 1, 1, 1. That is the pattern. Now, we're not going to solve this on this problem right here, but this is how you set it up. Okay, now in the next video, we'll start to solve these, okay? But this is how we set it up. And guys, this is what I'm going to have you do for your homework. Yeah, I mean, it's going to be kind of hard to type in. Do the best you can, as long as I can kind of see how your numbers are. Remember, 1 divided by 2 can give you that. I know the plus and minus thing will be kind of weird. So just type it in the best you can in the journal. I know that'll be a little weird. Okay, let's just look at this other one. Obviously, the vertex points can be negative. So we've got negative 2, 4. We've got negative 1, negative 3, and 3, 1. Now, one cool thing, guys, the order doesn't matter. Like over there, I picked like 1, 2 to go first, but I could have picked 3, 7. The order doesn't matter. So I can start here, I can start here, I can start here, okay? But we do, remember, always at the beginning, have a net plus or minus 1/2. So in front of the formula, in front of this matrix is a positive and a negative 1/2. Again, it doesn't really matter. I'm going to go ahead and start with negative 1 and negative 3, negative 2, positive 4, and then 3, 1. But again, the order could have been, I could have started here and went here and then here. I mean, the order doesn't really matter. And then remember, the last line are always positive ones. So there's my 3 by 3 matrix of that triangle. And again, in front is a plus or minus 1/2. Okay. Now again, we're going to start working with this on the next video, and this will make more sense. Okay, but this is how we set these up. So what I want you to do on your homework or assignment here in your journal is just take that triangle. So the vertices are 3, 6, 5, 2, and 9, 7, and just set that up into the 3 by 3 matrix, okay? Just set that up into the 3 by 3 matrix, okay? And that'll be your assignment for this video, okay? Thanks, guys. Take care. We'll see you next time. Bye.